Welcome to The Explainer. Today, we are talking about the absolute massive stakes of rescuing a multi-billion-dollar offshore mega project. We're looking at turnaround operations and specifically the famous roadmap used to rescue the Girassol FPSO project. Because, when a mega project of this scale flatlines, every single day sitting idle literally burns millions of dollars. So how do you shock it back to life? Well, let's dive right into the anatomy of a project rescue. All right, let's dive into this. When you hear about a multi-billion-dollar offshore project suddenly stalling, you probably picture, a massive, dramatic disaster, right? A strike, a catastrophic fire, or maybe a huge bankruptcy in the supply chain. But the Girassol project? It didn't stall because of any of those things. It stalled because of one single missing dataset. Literally, one set of numbers just never arrived.
It's just wild to think about the micro to macro juxtaposition here. Over in Paris, the engineering team failed to send one specific data packet, the topsides hull reactions. And because that one tiny packet didn't make it to HHI in South Korea, an entire 8,000-ton hull construction was completely, utterly frozen. The design couldn't be finalized, and those massive yard cranes, they just stopped.
Which brings us to our first section, the diagnosis, why one single number stops a whole shipyard.
To really get this, we've got to look at the physics. Hull reactions are the downward forces that the topsides exert on a hull structure. Basically, the topsides sit directly on the hull and push down with immense force. We're talking massive dead weight, dynamic motion loads, basically everything the unpredictable sea throws at them. The hull's structural scantlings must be perfectly, meticulously designed around those exact forces. So here is the fatal chain reaction. Step 1, engineering provides no reactions. Step 2, because you don't know the forces, you absolutely cannot have a finalized hull design. In step 3, without a design, no steel gets cut. You literally cannot build the hull. Without that fundamental data, the whole project just hits a brick wall. So, what's the cure? Section 2, the defibrillator, a 4-step rescue. To shock pace this flatlining project back to life, the recovery team deployed a brutal but honestly absolutely necessary 4-step management framework. These vital levers are leadership, ownership, incentives, and relocation. And listen, you need all 4 working together to actually pull this off. Let's start with step 1, leadership. And honestly, it requires a heavy hand. You replace both the project director and the technical director. But wait, this isn't about punishment. See, a stalled project has developed a toxic, normalized culture of accepted lateness. The people who allowed that delay to become normal simply cannot be the same people tasked with unnormalizing it. Bringing in new leadership instantly resets what acceptable means, literally overnight. Moving to step 2, we have what's called managerial augmentation. You absolutely must break the massive, overwhelming scope into manageable pieces that a single human being can actually own. By appointing deputy engineering managers and area managers, you make sure that nobody can hide behind a giant unowned block of scope. A stalled project usually has no clear owner per area, meaning no one is held to a date. This move completely fixes that. Step 3 tackles the commercial reality. And I just love this quote. If your subcontractor makes more money by going slowly, no amount of progress meetings will make them go fast. It's so true, right? It's basically the golden rule of project management. You have to fix flawed contracts because a progress report is never going to beat a financial incentive. So how do you actually fix it? Well, you fix the incentive, not the reporting. You move your subcontractors onto target price plus incentive schemes. When you align their commercial interests with your schedule, meaning their bonus curve physically rises when engineering milestones are hit early, boom, the supply chain immediately starts moving in the exact direction you need. And then there's step 4. Relocation. You relocate the integration scope to a high productivity yard. In the Girassol case, this was HHI. Now, I know this might seem totally counterintuitive, but the reality is you've already lost time in upstream engineering and you just can't get it back. So you buy it back downstream. By utilizing a yard with incredibly fast fabrication speed, you partially absorb that late engineering. You aren't actually fixing the delay, you're purchasing tolerance for it. Now for section 3, the medical philosophy. Stabilize first, autopsy later. And this brilliantly illustrates the exact mindset you need. Think of an emergency room. When a patient arrives after a bad accident, the trauma team doesn't spend the first hour debating whose fault the crash was, do they? No, they stabilize the patient. On a stalled project, you must stabilize first by fixing your leadership, ownership, incentives, and capacity. Writing the lessons learned report and establishing blame, that can completely wait until the project actually has a pulse.
So let's test this logic against a real-world scenario. Imagine a recovery plan lands right on your desk, and it proposes exactly one solution to save the project, adding 60 extra engineers. What do you think? Will that actually work?
Actually, scratch that. It's not even a maybe. The answer is almost certainly no. Headcount is the absolute last lever you pull, never the first. Think about it. If you throw 60 extra engineers into a project that still has totally misaligned incentives and no clear area ownership, you don't get faster engineering, you just add 60 more people to the confusion. To summarize the whole shebang, true project recovery requires leadership, ownership, incentives, and capacity, all working together. Simultaneously, always look for the missing data set before you look for the missing effort. Which leaves us with a pretty critical question for your own industry. If your biggest project stalled tomorrow, would your leadership team have the courage to stabilize the patient, or would they just waste millions performing an autopsy while the patient is still bleeding out? Thanks for joining this explainer.